Hello students, welcome once again to Chem is Try. In today's video, we have a practical question on the board, and it is a question found in volumetric analysis. Let's read the question together. The quantity of calcium oxide, CaO, in a rock sample can be determined by treating a known mass of the powdered sample of the rock with excess dilute HCl, and then titrating the unreacted acid with a standard alkali. A is a solution obtained by reacting 4.2 grams of powdered rock sample with 1.00 decimeter cube of 0.180 mole per decimeter cube HCl solution. B is 0.100 mole per decimeter cube NaOH solution. What are we going to do? A. Put A into the burette. Titrate 25 centimeter cube portions of B against A using methyl orange as indicator. Repeat the exercise to obtain consistent titers. Tabulate your burette readings and calculate the average volume of acid A used. The equations involved in the reactions are, we have two equations. 1 mole of calcium oxide combining with 2 moles of hydrochloric acid to produce 1 mole of calcium chloride and 1 mole of water. The second equation, 1 mole of hydrochloric acid combining with 1 mole of sodium hydroxide to produce 1 mole of sodium chloride and 1 mole of water. From your results and the information provided, calculate the I, concentration of excess HCl in A in mole per decimeter cube. II, amount of HCl that reacted with 4.2 grams of rock sample. III, mass of calcium oxide in the rock sample. IV, percentage composition by mass of calcium oxide in the rock. That is the question. Before we go ahead to perform this titration, there is something we need to understand here. Let's look at the preamble to the question. It says that we have a rock sample, and that rock sample contains calcium oxide. But we want to find out the amount of calcium oxide in the rock. Now, the easiest thing we could have done is just add the rock sample to water, stir for it to dissolve, then go and titrate it with a standard acid. However, if you crush this rock into small particles and you pour it into water and you stir, the rock particles are not going to dissolve in the water. So in order to get the content of that rock sample, what we need to do is we can crush that rock sample into powdered form, then pour that rock sample into an acid. An acid will be able to dissolve the rock sample and also dissolve the calcium oxide in the rock sample. But the acid we are going to use is supposed to be in excess such that all the rock sample are going to dissolve in the acid and you are going to get excess acid left. Now, the moment you get a question like that, it is not a normal acid-base titration. This is what we call back titration. Another example is, you know there are calcium carbonates in eggshells. So we can take some few eggshells, crush it into powdered form. We want to find the amount of calcium carbonate over there. But these eggshells will not be able to dissolve in water. So we will not be able to find the mass of calcium oxide in the eggshells. But what we can do is, we can dissolve these eggshells in excess acid in excess acid, so that the calcium carbonate found in the eggshells are going to dissolve in the acid. But since the acid is in excess, the calcium carbonate will all react, leaving behind additional acid. So in that case, the eggshells become the limiting reactant, the reactant that gets finished first in the reaction. Then that excess acid that is left, we are going to titrate it with a standard base. In another example, you could be given an ammonium salt. Then we want to find the amount of ammonia found in the ammonium salt. What we do is we take the ammonium salt. This time, we are not going to dissolve the ammonium salt in acid. Rather, we are going to dissolve it in a base. A base like calcium hydroxide or potassium hydroxide or sodium hydroxide. But that base should be in excess, so that it will release all the ammonia from the ammonium salt. Then the excess base will be titrated against a standard acid. So in a back titration, there are normally two equations. One is about dissolving the content of your sample in excess acid or excess base. In this question, that is our first equation. The rock sample contains calcium oxide. So we dissolved it in excess hydrochloric acid. So all the calcium oxide will be converted into calcium chloride and water, leaving behind some of the hydrochloric acid, which is in excess. So that excess hydrochloric acid will then be titrated with the sodium hydroxide. That is back titration. So in the exam, you'll be provided with two solutions, solution A and solution B. Your work is just to perform your simple titration. But there's something at the back of your mind. That solution A is a solution obtained by dissolving either an acid or a base, using it to dissolve your sample. But that acid or base is in excess. So let's go and perform the titration. Then use the titration to determine the average volume of A that was involved in the titration. This is the titration reaction. Then we will use that one to go back to find the amount of this hydrochloric acid and use that one to find the amount of calcium oxide. So let's go and perform the titration.